Hello. So guys, last time after the class, on the next day, I gave one assignment. So have you guys checked that? Or anyone of you able to complete it or even tried? Mm-hmm. Mm-hmm. Okay, okay. Anyone had any problem creating those tables? Okay, everyone was able to create. That's cool. So everyone was able to insert the data into those tables, like any dummy data. Then you might have tried the queries. Okay, let me share my screen and then we will go through the assignment. So this was the assignment where we had to create some tables for the food delivery application. So when we talk about a food delivery application, it will have restaurant, it will have the menu card for each restaurant. Then we had some delivery persons who will deliver the food. Then we have some customers and the orders they will create. So order table something look like this. Some particular order ID. This is the menu item that this particular customer have ordered. This is the quantity they have ordered, and this is the delivery person who might have done the delivery. Okay. So I guess creating these tables are pretty much okay. So if I just give a quick snapshot. So I was just doing these things just a few minutes back. So I created these tables already. Uh, so if you wanted to see the already created table, like what is the schema, what is the create table statement that you have written. So to get that, you can see you can say show create table and the table name. So that will give you the entire create table statement that you had given for the particular table. So here you can see I had given the create table customer, the customer ID which is integer not null, and the auto increment, and then registered the primary key on the customer ID and the customer name, like that. So similarly we would have created all the tables with all the relationship with the foreign keys and the primary keys, and I created some dummy data in my orders table. Okay, now let's go through all the questions one by one. So this fetch list of customers who have ordered more than 10 items. We had to fetch the list of customers who have ordered more than 10 items. When we say number of items, we had to we can simply see that this particular quantity is my number of items. And right now, since there is no such order where someone have ordered more than 10 items, the query should return me 0 result. So how would I write the query? I need to fetch the list of customers, which is customer ID, from my orders table where my quantity is greater than 10, which is empty since I don't have any customer who have ordered more than something greater than 10. Okay, the other way around to look at it is like yeah. So if this particular customer, see, this customer 3 have ordered one item, then this customer 3 again ordered some another item of quantity 2, and some another item again quantity 2. So the cumulative number of items the customer have ordered it could be he could be asking who have ordered more than 10 items, because each item would be different, and it doesn't matter to us what item he have ordered, what, like either he ordered burger or chow mein. We doesn't wanted to look at that part. We only wanted to look at the total quantity. So we had to do the grouping, we had to perform the aggregation. So how will it go? Like we will do the customer ID, and we will also take the count, like just to showcase it. I am writing it in the select statement, not the count. We had to make the sum. So this quantity as, let's say, total total order from my orders table, which I am grouping on my customer ID, and saying having my total orders greater than 10, though it will return me empty set because the customer 3 have ordered 5 elements. So if I just don't remove the where having clause, then it will say me the third customer ID 3 have ordered 5 total orders. Now you might have this, like we had this having, I performed the filtering using having, but earlier we discussed that we are performing the filtering using where clause. So here is one cache. See, when we perform the group by, so this will create a separate table. So there is a concept of subqueries as well. We can treat this query. So this table, this particular query will return some table. I can even query this table, or can select on any, or even can write a query considering this statement as a table. Whatever table, after executing this query, whatever table it will return, I am running the SQL on top of it. Now I wanted to select the customer ID from this table. So what will I get? 3. Basically no difference. I am connecting, see, we had a server, SQL server, which is running behind. Even your workbench connect with the SQL server and executes your query, like it just provides you a nice UI on top of it. You can also run the command line version. At the end, what we are all trying is to run the SQL statements. Got it? So this, we are from the orders. Every derived table must have its own alias, as it is saying. So we had to give some alias to it. So let's call this table I. Okay. So we are able. This is how we perform the subqueries. So this is the concept of subquery. Whatever query we create, we can consider that query as a table, and then we can use the table to query something else. Here, this is my query, and this is my subquery, and this is my query on top of this subquery. And while doing the subquery, we are bound to give the alias Like by alias, what I mean is whenever we are mentioning tables, so we can refer the table with some identifier. Let's say in this case I said this table as I. Okay, back to our question. Now what I'm trying is I was trying to give you difference between having and where, because above I filtered the records using the having. So you can do the same thing by using the where clause, but for this you had to put this in the subquery. Why? Because where clause will apply on the particular data set directly when you are fetching the records, but here you are first creating the group by. So the total orders up until this sum is performed, the total orders doesn't exist, right? Only quantity exists. So once this quantity this sum is performed, then only I have to do the filtering part. So I am doing, like when we say having, we after performing all the query, it will use the having clause. But when we say where, so before performing the group by query, it will perform the where. So we put it into a subquery. Subqueries are always performed first. Like all the subqueries will perform first, then the outer query. This is the priority. It is the order in which this queries is executed. So I can write it like this: total orders is greater than 10. It will result in the same one. Alright, so this is about the first question. Let's move to the other one. Fetch order table with menu items names with it. Right now if I see my orders table, it looks something like this. I don't have the menu like which particular menu item they are ordering, it's just IDs. And if I see my menu table, this is my menu table, which looks something like this. So what I need is, I wanted to fetch my orders table along with my menu item names. So what I need to do for this? Simply join. What sort of join I can make? Is it should be left join, inner join, or right join? So here, since we only wanted to fetch the orders table and the related menu items, so what we can do, we can perform the left join, because if we so we should perform the left join. We can also perform the inner join, because we know all the menu items we have here will also be there, because it's a foreign key relationship. But just to be more precise, in the data warehouse scenario where we don't have such constraints, let's say if we don't have this constraint, and there could be missimilarity where we have the menu ID here but we don't have the specific menu item related to that. So in that case, it is best to use left join, because we only wanted to fetch the records which are present in the orders table, as the question statement suggests. Fetch the order table. We only had to fetch the records for the order table with the menu items. So it's a simple join. I guess everybody have done it. Like select star from the orders table, left join the menu, and on which menu ID. So should I skip it, or I will quickly just write it? Orders table, let's say O, left join my menu table m on m dot menu id equals to o dot menu id, and apart from doing the select star. So I wanted to select all the records from O and only one record from my menu, which is my what is the dish name. So we got the dish name corresponding to my particular IDs. Okay, let's go to another question. Fetch the customers who have ordered value more than $1,000. Now we had to fetch all the customers which have ordered value more than $1,000. Now if you look at the schema, you have order IDs, you had the menu. So to reach to the price, how can you reach to the price? You have the corresponding price to that menu in your menu table. Okay, so it is evident you had to join this menu table to get the prices. And what is the price? It since the prices that are mentioned is for the single dish, and here we had the quantity as well. So the total price for the particular order could be the quantity times the price for the dish, right? So we just had to mention in terms of SQL. So let's say from this statement I was only fetching the dish name. So instead of just dish name, what I will do, I can create a column which would be saying that my price multiply by the order quantity as my total price for the item which have been ordered. Okay, now if I do this, you will see these are the prices based on the quantity. And what we wanted to find out, what is the who is the customer who have ordered more than $1,000. So the other thing what we have to do is we have to group on the customer ID to sum up the total prices. Then only we are able to identify how much price they had paid, right? So we can mention that in a subquery, like just to make things simpler. So what we are doing, we are selecting the customer IDs and my sum of the total prices from this table, inner table. We have created this table. Now I am using it as a subquery from this table, and at the end I have to say where I am having my this total price greater than this $1,000. Like I'm not doing it because anyway we will get the yeah. So we have to say group by on my customer ID. So this is how we give. So we can say having greater than $1,000, it will fetch all the customers which have ordered for more than $1,000. Now you might be getting hang of it, like how to write the query, how to answer the questions. Any questions still here? Sure. I just wanted to show both of the things in the same window. Let me just maximize it. And let me also change the settings. Able to see? All right. So any questions so far? Like, are you guys clear with the joins, the where clause and the subquery part? If it is okay. So when we say subquery, like by the name itself, it is a query within a query. All right. Now when we talk about a subquery, so whatever is mentioned in the brackets, it is having the first priority to execute. Like now this is a subquery, so first this will execute, and the result of this subquery will be treated as a table. Let's say this particular query is we have executed above, right? So this is my query above. So here you can see this particular query result in this particular table. Then I can use, when I use it as a subquery, so the external query will treat this as a table instead of a table name. Like here I am giving a table name, the orders, but instead of a table name I can give a subquery. Like after executing the query, whatever table I will have, I have to query this table. It's a nested thing. Got it? Okay. So I will not write the query for everyone. I will just explain on the top of. You can try it yourself, and then we can discuss in the next class. Or you can post the question directly in the group. We will discuss it there. So if you guys are having problem solving the rest of the questions, like for the fetching the order table along with the restaurant names, orders tables, you had to fetch the restaurant name. So if you see order table, you had the relationship with the menu ID as a foreign key, and menu table will have the relationship of the restaurant ID as a foreign key, and here you got the table name, the restaurant name. So to fetch the restaurant name, what you had to do? You had to perform two joins. First, you can perform the left join on this menu table, and then you can perform the left join of on the restaurant ID with the restaurant table. And using that, you can fetch all the restaurant name in the like parallel to the order table. Got the idea? Okay. Talking about the fifth question, like fetching the total sales according to the location. Now here you can see we are asking for location according to the location. We wanted total sales, and where we have the location? We have the location of the restaurant. Like for a city, in like wherever the restaurant is present, there only he will like we are making this assumption. Wherever the restaurant is present, let's say restaurant is present in Pune, then he is only serving to that particular city only. He is not doing any intercity transaction. So if we try to gather the location, total sales by location, what we had to do? We had to make a join based on the menu table. We had to gather the price. How we gather the price here? As well as we had to make another join to fetch the restaurant name. Like we had to make a join with the restaurant table to get the locations for the restaurant based on the restaurant ID, and then we can perform the group by on the location. Any doubts? Like this might be, if you want me to write this query, then I can just explain. Okay. See, we get the menu ID from here, and above only we are fetching the price. So right now I'm not doing the group by on the customer ID. So after this we already have the menu ID. So what we will do inside the subquery itself, I can make another join, left join. Which table? Restaurant table. RESTAURANT. Left join this restaurant table R on my restaurant, where R dot restaurant ID equals to M dot restaurant ID. So after running this query, I'm writing this inside the subquery. So after running this query, I also got the restaurants and its locations. So I need to get the total price. Along with it, I will also have the locations for it. And just to give you a look of the subquery, how it looks, we will first execute the subquery, and then I will show you like what we are grouping. Here you can see all the locations are Pune. We make two joins, one on the menu ID and then over the restaurant ID from this menu ID. We got the locations as well as the total price. Now on top of this table, we are just what we are doing is we are grouping on the location and summing up the total price. That's it. So to perform this, grouping by on location, and we are selecting the location and the sum of the total price. As let's give a name, cumulative price from this. So total Pune have done the business 1200, 1450 rupees, like this. Okay, is everyone clear? Okay. Like the sixth question is fetch list of restaurants with the number of items they offer. It's simple thing. We had the menus, we have the restaurant ID, we had to fetch the total dishes of the restaurants. You know which one to group by on, and you had to perform the count or sum. Can you? Your voice is breaking. Okay. Here? Okay, you can take the screenshot if you want, like just for reference. Alright, can I change the screen? Okay. Yeah, talking about this fetching the list of restaurants with the number of items they offer. It is pretty straightforward. I guess just a simple join and the grouping by. Try that on your own. Then trying adding one more attribute, the nationality in the delivery table. Like this is about the altering of the table. Right now the delivery table doesn't have the nationality of the delivery person. So what you have to do, like if right now if I see my state of the delivery person, like we had two persons, we don't have the nationality, we had to add one more column to it and populate that column. Okay, so this is straightforward, like it's I am leaving that up to you. So this was our assignment. So any questions on this SQL assignment, you can ask now, then we will move towards advanced SQL. Mm-hmm. Basically the questions will be something like this only, or they could be complex, but as long as you are able to think in terms of SQL. See, here we wrote only a single subquery, but in when we talk about the job, we write multiple subqueries. We perform group by, we perform join, like. But in the job interview, they will only ask you basic questions like, are you able to convert language statement into SQL queries? That is why I created this assignment. Like this is a real life example of a food delivery application. The data model something look like this. Like I created only small very few attributes, but when we talk about the data model, we have the schema types like a star schema, snowflake schema. So this is somewhat of a star schema, but we are not discussing the data models here. We are discussing the how we can convert the questions into the SQL statement and can answer those questions based on our SQLs. So this is what the interviewer will ask in a interview of coding part. Like basically in the data engineering interview, whenever we say the coding part, we usually talk of SQL. Okay. Okay. Okay, let's move to this advanced SQL. So basically in advanced SQL, what I am trying to explain is the window functions. Like right now, what you did is you had run the group by, you are able to perform the aggregations, performing the sum, count, averages, or you can slice and dice the columns, number of columns. You are able to perform some small functions on top of the column names. But there comes certain times a need where you had to perform running numbers and aggregations. Like let me just open the Excel and let me help you to visualize it. Then we will talk that in terms of SQL. So let's say let's consider our old example where we were trying to create a scoring system for a cricket tournament. So we had some players, player name, we had or let's keep it simple, player ID, we had the balls, we had the runs. Okay, this is scoring table, let's say score table, which carries the data like player ID 1 on first ball scores 3 runs, player ID 1 on the second ball scores 5 run, something like this. Player second player scores and the third ball some 6 runs. Now if there could be what sort of questions there could be, like which particular player had scored the max of the runs. So for that purpose you can simply perform a very basic aggregation function, like select the max of the run comma player ID and you will fetch it. But let's say what you wanted is you wanted to fetch a cumulative let's say a running sum. Because when we talk of runs, after ball 2 the total runs this player 1 have made is 3 plus 5 8 runs, right? So in that fashion we want the running number. But when we if we talk about all our aggregation function that we have learned till now, it is it will perform the aggregation on the total basis. We can group on the certain player, but it will not it will give us the total sum, like at the end if all the cumulatives at the end if we have 22, so it will retrieve us 22. But what we require is running number, because we also wanted to find out on a certain ball how much score the player ID 1 have. So for that SQL have window functions. So by the name itself you can see this is window. So we create a window over which we perform the calculation. So let's say we had the player we had some player ID, and now we wanted to perform the sum over a window. So how the window is created? We will create a window over by creating a partition on certain columns, and we can perform the ordering. Like there are two things that we can mention in a window, on which on which key we want to partition that window, and on which key we want to order that window. Like the syntax is like this, like my function over partition by the key and order by key. So this function could be anything, sum, average, or mean, or count, row number, like this. So let's say we wanted to do. So let's discuss about the partitioning and ordering. So when we say partition is on which particular key you wanted to perform the grouping on. We want the accumulation over the player ID. Let's say this one is here, and this is the fourth ball, and this is he had scored 1 run. So for this player ID 1, the accumulation will be 9 here, not this particular run is not from the player 1, right? So inherently we are doing some sort of grouping for a particular key to perform this running sum. If we don't partition, then what will happen? Then there is no grouping. My cumulative sum will include like 8 plus 6 14 and 14 plus 1 15. This will go like this. So this partitioning will help us to create the grouping, and order will help us to create the like on which particular key it will be ordered. Let's say if we order, since we are ordering here, we are ordering on balls, so we are having the sum like this, like for this it is partitioned on the player ID and running in an ordered fashion on the balls. So 1 2 3 4, so it is running the accumulation like this. But let's say if we perform the order by on runs, then what will happen? My the output data set will have this runs sorted, and I will have like 1. So if I take a copy of it, so I will have this little sorted 1 3 5, and I will have this running. Like this. So basically the order by decide on which key we wanted to order this thing. Okay, let's see it in example. We already had we had created one table yesterday. Show tables. So we had this scores table. Let's see if we have some data in this. Only single row. We have multiple rows here. Cool. But we don't have the running number on balls. So let's insert some data in the scores 2 table. Insert into scores 2 values. Player 1 have scored 3 runs on first ball, 2 runs in second ball, third ball is already there, 5 runs in fourth ball. So now if we see the scores through table, we have 1 2 3 4, all the balls, right? Now if you wanted to perform a running sum for this, so we can write this window function which are windowing on the player ID. How it is windowing? Sum the runs, like we are having the player ID, sum the run. Like by windowing means basically if you see, we wanted to perform some aggregation on certain when we say window, we say we will select a certain like this is my small window in which I wanted to perform aggregation. Like if I say group by, basically I am performing the aggregation on top of entire data. Like by, if I give an example, let's say if I say group by select player ID comma sum of run from this scores through table group by on player ID, what will I get? I will get the sum of all the runs with a player ID 1, right? So when we say group by, it will give it will select the entire table. Like we have the window is entire table itself. But when we say but we don't want it in this way. We wanted the window to be smaller. So when I am saying, so by window, let's say I fixed a small window by like I will only iterate I have created this small window and I will perform the aggregation in this. instead of aggregating on the entire table. So yep. So now what we since we wanted to do the cumulative sum, what is my window? My window will be like a small window of two rows where every time I'm just running the sum of this and this. So how I create a window? I create a window by these two parameters. Like I run a function, and the function that I had to run over which window? Over the window which is partitioned by a certain key and ordered by a certain key. Okay, so right now I performed a partition, let's say on the player ID. So it created a window on the player ID, and it is started applying that function ordered by this particular key. So let's say if my order by is ball, so it has started applying the sum function on this window. So sum, then sum, then sum, then sum, then sum. So as you can see, it is in a window. It is a small window. Now it expanding the window, keep on expanding the window based on the partition. Got it? Like what we exactly mean by window function. So we are creating a small window based on my partition by on the player ID, and I am having my window over the balls. Like I am ordering it on the balls as, let's say, running sum. From this scores to table. See, let me also fetch the balls as well, like to make you more clear. See, since you had said that you are making this ordering on the balls, that means you had the ordered balls and the window is on the player ID, and you had the running sum. On the first ball it is two runs, which is on the first ball it is 2 runs, then on the second ball it is 2 runs, so 2 plus 2 is 4, then 8, then 13. So after at the fourth ball, the total score that is scored by this particular player is 13 runs. Like anyone, like it could be a little confusing. If you guys have questions, just unmute your mic and speak up. Like that is the best way to understand the concept. So sum is just like I chose one function. So there are a couple of functions in the window functions that apart from the sum, average, and all those functions that we use in the group by, all those aggregation we use in the group by, we can also perform few window specific functions, which are, like, I will just mention it here, window specific functions. Let me just increase the text size for you. So those functions are, first is row number, row number, we had rank, we had dense rank, we had lag, lead, we do have quantiles as well, like percentiles. So we will discuss these, like which thing is used for what. and what are the differences. Okay, so let's first see the row number. So as said by the name, row number will generate a number. Like if I just hit a plain SQL query on top of it, and instead of this sum over the runs, what if I change it to row number? Now you can see row number will generate row numbers 1 2 3 4. So if I say this as a row number, now here since we are just saying the row number, it will generate the row number, but will it generate the continuous row numbers? No, it will generate the continuous row number only based on the window we define. Since we performed the partitioning on the key, which is player ID, so 1 2, it is not a record from this, so it will be 3 here, and this is the first record, so row number is 1 for player ID 2. Like performing the window for only player ID 2 is like this is the first record for player ID 2. So if there exists any other record for player ID 2 is then you will get the 2 here, because if you see the window for the 2, like this is one window, and this window will expand for this 2, and this window will expand for this partition key where the player ID is 1, because the partitioning is on the player ID. Are you getting the hang of it? Like how this row number is performing, like how this why the run, it is not exactly as a running number. Why is it 1 here? You guys understood it completely? Okay, I will take the silence as approval. So this is about the row number. It will generate a continuous sequence over the particular window that we will define in this based on the partition and the order by. Okay, let's talk about the rank. So ranking means like we had all seen the rankings in, we had studied class 10th, class 9th. Few students come first, then few students come second, third. So what are those? Those were ranks. So first rank is given to the person who is having the maximum score. Then second rank, like one step then lesser than the maximum one. So basically, whenever we wanted to identify the ordering over a particular column, like which one is the maximum, which one is the second maximum, third maximum, kind of, then we can use ranks. Like if I just take one example here, so let's take a small let's have a small table. Let's say we have employee salaries. Okay, so we had some employee, the employee ID, and let's say he had some salary. Okay, and we wanted to say fetch some employee ID. Let's say this, he earns 20,000, and this is some employee ID 2, he earns 40,000, and this is some employee ID 3 who earns like 30,000. Okay, so basically if I talk about the rank, he earns the most, he earns the least, and he is the second one. This should be the rank, right? So how we will get this rank? This rank is if we create a window since we don't want it to create the window on particular partitioning, because it is a running rank over the entire period. So we can simply leave the partition by step, because we don't want it to partition on certain key. Otherwise, let's say if we partition on key, let's say if we partition if we don't partition it, let's talk when we don't partition it. So if we don't partition it, then we will have the entire window running, all right, and which is order based on the salary. So based on the salary, since it's ordered on the salary, we will get the ranks: first rank, then the second rank, then third rank, and we will get the sorted rows. Like I guess you guys looks blank. Let me just create a small table and show it to you. Table employee, and we have the employee ID, which is carry integer value, which is not null, and let's say it is a primary key as well, primary key. And we had salary, which is again an integer, let's say, and it is not null. Okay, and we insert some values, insert into, let's say we insert these 3 values. So insert into this employee table where my values are, like first employee is having the salary of 20,000, the second employee have the salary of 40,000, and the third employee is having the salary of 30,000. So this table looks something like this, as we mentioned in Excel. Okay, now we are talking about the ranks. So when we don't perform the windowing on when we don't select any partition key, okay, so basically we are not partitioning our window on anything. That means I am my whole table is my window. So this is my window, and I will keep on expanding this window. Since it is order by on the salary, I will order it by on salary. So first I will order it by on salary. So this will look something like this, which is like 4,000, 2,000, 3,000 if I order it by descending, and then it will perform the ranking on top of it, like first, second, third. Make sense? So let's try this out. Select my employee ID and the salary as well, let's say, and we will perform the ranking over. I'm not running any partition, which is order by on the salary. So right now as rank, okay, from table employee. Yep. So here you can see right now, since it is ordering, when we say order by, it is always ascending. If you wanted to do it descending, like the maximum one, so we had to mention just DESC, like descending, order by salary and DESC. So this will just give the descending one. Okay. Yeah, sure, we can do that, but it will just plainly it will rank 1, 2, 3, because there is no ordering and there is no, so everything is a first rank, because it have nothing to compare for. Yep. And even let's say if I show you, let's say I was talking about, let's say if we use partition by filter, partition by as well. So but if I use partition by on a certain key, let's say if I partition it on employee ID, what should be my rank? for this yep, this should be my answer. Why so? Because since I am partitioning my window on my employee ID, so this is my window, and this will be the max size of the window. This window cannot expand because there is no employee ID as one again. Got the concept of the partition by and order by? Like if I just for illustration, if I show it to you, partition by employee ID. No matter whatever ordering I give or I don't, this will give 111. Even if I give ordering, doesn't matter, because inside the single part inside my employee ID partition, I had only single record for the specific employee ID. Got it? So this is about the ranking. Now let's say I insert one more insert into this employee table. Employee, the values which I wanted to insert are, let's say we had the fourth employee which have the salary same as the first one. Okay, now my table looks something like this. From employee, see, now I had a competing values. I had the employee ID 1 and 4 as a 20,000 salary. So if I perform a rank, like if I talk of a traditional schooling system, even let's say two candidates have the same score, then both of them are on the first rank, right? Rank will only change when you're when there is at least a small change. So if multiple candidates can have same ranks, like this is the concept. So if I try to just do the ranking part according to the salary descending, so now I will have the third rank for the first employee as well and the fourth employee as well, because they had the same salary. So we cannot decide who is the fourth rank. Okay, so this is one thing that we had to consider while using rank. Wherever we have the competing values, wherever we have the similar values, it will only like multiple rows can have same rank. But let's say if we don't want this behavior, what we want is like I should not have similar ranks for two rows. So for that we have dense rank. Why dense rank is given? Okay, I will come to the dense rank later on. Okay, like if you don't want to let's say if you don't want the competing ranks, like now you have seen the row number, you have seen the rank as well. Okay, in the ranks we have seen that we can have same value, same rank for multiple rows. So if we don't want this same rank on multiple rows, what we can use? We can simply use row number as well. Anyway, rank is what? We are just giving an increasing number on top of based on whatever we are doing the ordering on, and on whatever keys we are partitioning on, right? So if we generate a row number on top of it, then it is still the same, right? And row number is always increasing. It can never give same value for 2 rows in a same partition. So if we see here, now we'll have this first as a third row number and 4 as a fourth row number. So how it is decided that whether 3 is given to 4 or 3 is given to 1? Yep, based on the based on the representation, like internally, right here. Here, if you see, the first is inserted before then 4. So this is the sorting of the current table. This is how the rows are there. So while calculating this row number, so whichever row come first, so 1 came before. So here you can see 1 came before 4, so 1 will be given precedence. So 1 will have the third row number and 4 will have the fourth row number, like this. Otherwise it will stay the same. Now there arise questions like, let's say, who is the one who have the second highest salary? We had to find the employee ID who have the second highest salary. So we can now we had the knowledge of the window function. We can find that. We just have to perform the filtering, right? We wanted to find third highest salary or fourth highest salary. Just perform the row number, or we can just perform the rank and we can get the output by filtering. So this is about this row number and average, these ranks. Now let's talk about, let's say I wanted to find out the difference, salary differences, or let's say if I go back to the example of my players' balls and runs. Okay, what I wanted to find out is, do we have a hat trick? Like, did my player 1 scored the hat trick or not? A hat trick is a hat trick. Let's say if I got 4 4 4, that means he scored boundary 4 times. That means a hat trick, right? So to do that, what I can do? So for that, I need to, for a current row, I need to know what is my like do my previous row had that value equals to this current value, and my leading value is equals to the current value, right? This is the requirement I need. So to get the to get the lead and the lagging rows, we had these window functions lag and lead. Okay, so what it do is, let me just give you an example on the employee ID, then we will just cover up how to gather the hat trick part. Okay, using the lag and lead. So basically, let me just copy the above code. Basically, you can see in my current table, it looks something like this: my employee IDs and the salary, and at the particular employee ID, I wanted to also get the salary for my previous employee ID, and let's say I wanted to find the difference of my current employee ID salary with my previous employee ID. Okay, so for that, what I need to get the previous row, and to get the previous row, what I can do, I can perform a window on which partition. Since I don't have any partitioning key, I don't want to create a window on a specific keys, so I will leave the partition by as it is. Like I want to do the partitioning. I can simply say ordering by the employee ID, because I want the salary differences of the current employee ID than the previous employee ID, and the current employee ID is 2 and the previous will be 1. If I order by on salary, then it will I will mess up with my employee IDs, right? Mess up with my ordering of the employee ID, which I don't want. So if I just simply say lag, so this lag function accept two arguments. One is on which particular key you wanted to see the previous value, which is my salary, and how much previous I wanted to go, like either 1 step back or 2 rows back or 3 rows back. So for now I wanted to go 1 row back only. Like for 2 I wanted to go 1 row back and fetch 20,000. Grab salary from the employee table. Okay, I ordered it on salary, which I said the same thing. Like we don't have to order it on salary because it will mess up the employee ID. Our task is to create fetch the salary differences of the current employee ID than the previous. So we had to order on the employee ID. Cool. 1, 2, 3, 4. Now if you see the salary here, since the first value doesn't have any preceding value, it will be populated as null. Now if you see for the second value, 40,000, and the previous value is 20,000. Similarly 40,000, 30,000. This is how you can select the lagging values for a particular column. If I wanted to select the leading values, then what I had to do, I had the same function lead salary comma 1. I wanted to lead as next salary from the employee. So using the lead function, we can go forward with the window. Okay. So if you see in my current window, the previous value is null, and the next value is 40,000. Next value of 40,000 is 30,000, and the previous value 20,000. So if I wanted to go 2 values further, I will change this parameter. Instead of 1, I will say comma 2. So it will go 2 values further. Okay. So now we had a bit of idea of what lead and lag is. So can someone answer me, like can someone unmute and answer me how to find whether certain player had performed a hat trick or not? And order by on. Cool. And then we will just perform lead, one lead, one lag, and if I had all these 3 values equal, then it is my hat trick. Okay, you guys, I might have forgotten to tell like the if else statement in this table. Like as we know, like if if I wanted to create something like this, let's say if my salary is greater than 20,000, then I will say true. Or if my salary is greater than 30,000, then it is true, otherwise it is false. So this will be true, and this will be true, and this will be false. So you guys know how to do that. Did I talked about case when statements? Okay, all right. Let me talk about it. So basically, to perform the conditional statements, by conditional I mean we wanted to give a condition, like if this is equals to this, or if my particular thing is greater than something like this. So these are the conditions, right? So to make the conditional statement, what we do is we use case when statements, like to say, let's say wherever my salary is greater than equals to 30,000, I will say true, otherwise false. So case when, or let's say instead of true or false, let's say the person is rich and the person is poor. Okay, so now to make that, we had to write a condition. So case when my salary, are you able to see it? Let me just increase the text size. When my salary is greater than equals to this 30,000, then say rich, or else poor, and. So this is how we write a conditional statement. We can write multiple conditions by using and, like and the, let's say employee ID is should be equal, greater than this, greater than 2, or something like something like this. Like if we wanted to increase the number of conditions, we can like append it and or conditions. Let me talk about and or as well. So first I am talking about this case when. So here using this case when, we can write these statements, conditional statements. Okay, like I wanted to say the same thing, like where my salary is greater than this. So I am selecting the employee IDs just for the references, and then let's say case when my salary is greater than equals to 30,000, then do the rich, else it is a poor. So every case statement, case when statement will end with and. If you forgot this and, this will show you the syntax error. So now I can give it an alias as like condition, let's say economic condition from this employee table. So might be this one support, otherwise. Check the manual that correspond to. Rahul, you're on call? Like whenever we forgot some syntax, the very quickest way to do so is Google. Okay, case when in my SQL. So that will just give you how it is to be done. So simply it gave us a syntax: case when, the condition, then, and else. If you wanted to say something like if this condition doesn't met, then else, and end. Is it not allowing me to use greater than equals to, or what? Yep, it is like that only. Like let's say if I remove the alias. Okay. Cool. So if we had to give the alias, we had to give it inside. Like this is the syntax. Okay. Apart from it, yeah. So so this is how we can make the statements. So to perform this thing, what we want is we want our lag and lead equals to the current value. So the statement that will go is like case when the lag value equals to the current run and the lead value equals to current run, then it's a hat trick, else null. And so this is some kind of a statement that we can make, and we can filter on the records where we have the hat trick to identify which particular player had performed the hat trick. All right. So this is about the window function. Like basic thing that we had to remember about the window function is on which key we wanted to partition it on, and on which key we wanted to perform the ordering on. Based on it, so these two parameters will decide our window, and based on that window we will perform the operation. We will perform this function, whatever we are saying. Like this is a very powerful technique, and which like it will come from practice, like which people often get confused on which key to partition on, which key to order on. So for to practice that, I will send you some assignment, okay, and that we can discuss in our next session, and then we will move on to Python. All right. Any questions? Okay. Okay, if no questions, then I guess we can close the call. Are we good? Yeah, basically the percentile is again the same thing. Percent. Yeah, you will give the column name and comma the percentile value, so it will give you the percentile in that window. So you might aware of what percentile is, right? Basically a percentile is when we say we know what exactly a percentage is. Like if we had the 500 we had 500 values, so let's say we had the total of 100, we got 80 marks out of 100, so it means 80%, right? So in percentile, it depends on the values. Like the highest one will consider the maximum percentile, which is 100 percentile, and all the values are relative to that maximum in the percentile values. So this is how the percentile is calculated. This is particularly used to calculate the distribution of the data. Like it's more of a statistic terms. But from a general perspective, like no one asked for the percentile, so I didn't discuss it. The topic will be on Python. Like we will start the basics of Python, and then we will proceed towards like creating a small program just to help you understand and get a grip on the language. Okay, then any more questions or can we close? All right. Okay. Have a good day. Thank you.